Hey everyone. Hey, get out of the way. Go. There were some questions about chapter 11.1 and how to compute the slope of the tangent line. And so I wanted to show you one of those and just work one of those problems out for you. So this is chapter 11.1, number 1. If we have f of x equals minus 3x squared, and I want to know what is the slope of the function at x equals 1. Okay, and to do that, we have to take the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so that's our goal. So let me move this aside. Okay, and what I like to do is compute these two things separately. So f of x plus h, sorry, that's an x, is going to be minus 3 times x plus h squared. Notice it's very important. We plug the x equals 1 at the very end. We don't use it yet. So this is going to be minus 3 if you FOIL this out. So that's x plus h times x plus h, right? And you do first 2, outside 2, inside 2, last 2. If you do that, you will get x squared plus 2xh plus h squared. So if I distribute the negative 3, negative 3x squared minus 6xh minus 3h squared. Okay, and we have our other term, f of x is minus 3x squared. Okay, so now we're going to take these two and we're going to plug them into our definition for the slope of a tangent line. So I'm going to take the limit still as h goes to 0 of f of x plus h, so that's this guy, minus 3x squared minus 6xh minus 3h squared, minus f of x, so that'd be minus a negative 3x squared. Oh, minus times minus, this will become positive. Hey, look at that. These cancel out. They must cancel out. The things without an h in them have to go away. If they don't go away, you had a problem. You did something wrong with the algebra. The terms without an h must disappear because we have to cancel this h out, because when we put h equals 0 in, we can't get a 0 in the denominator. That ain't cool. So we got to make sure that goes away. Okay, so now we should be set up so we can cancel the h's out. And so if I look here, I see, oh, let me rewrite what I have. I have a minus 6xh minus 3h squared over h. Well, I can factor an h out of each term here. So I can write this as h times minus 6x minus 3h all over h. Cancel, cancel. I'm going to get minus, running out of room, minus 6x minus 3h over, that's it, because we canceled out the denominator. Now when I plug h equal to 0 in, it's going to wipe out this term, and we're going to just be left with minus, that is not a 6, minus 6x. So this is the slope of the tangent line. This is the derivative of this function. So slope of tangent line is the same as the derivative. So I think they talk about derivative in chapter 11.2. But the slope of the tangent line is the same as the derivative. So now we can go ahead and put in our number here. So the slope of the tangent line is going to be equal to minus 6 times 1. It's a 6. There we go. Minus 6. So to recap, I write my function down. I calculate these two things. Let me go multicolor. There we go. So I'm going to calculate this one and have that one there so I can see it. And I plug them into the equation. So here it is. And there's always a term without an h. Always, always, always. And that term has to cancel out somehow. If it doesn't cancel out, then you cannot solve the problem and you're in trouble. So we canceled those out. I rewrote it, and then I factored the h out. You always have to factor the h out so you can get it out front here and see what's left over. And these cancel, and we're left with this. We plug in h equals 0. Boop, we wipe out that term, and we end up with minus 6x squared. So minus 6x squared is the first derivative of minus 3x squared. Minus 6x, sorry. So minus 6x is the derivative of minus 3x squared. And then if we want to know what the slope is, at any point, we can plug the x value in and plug it in there, and it's going to show us that point. Okay? That's how it works. So if I want to show, let's see, new, don't save. So if I want to show the graph, so f of x equals minus 3x squared. So I know this is a parabola, and I know it faces down because of the minus sign in front. And so it's going to look like, whoop, like that, whoop, and like that. And so the tangent line at x equals 1, let's see, how do I do this? Oh, here. No. There's a way I can draw a straight line somehow, I thought. And here? Oh, yeah, there we go. Okay, so the tangent line is going to look like that. It's tangent to this point right here. The tangent line here is like that. So we found at x equals 1, so right there, the tangent line has a slope of negative 6 is what we came out with, right? Because the derivative was, you'd show the derivative like this. This was the derivative. We plugged in x equals 1 right here, boop, and we get the slope of this tangent line, which was negative 6. Okay? That's all there is to it. So if you have any questions, I got office hours today at 1. Come on in and ask questions. Otherwise, have a great day. Bye.